In this example problem, we are going to be using the regression equation to predict a property's taxes based upon the size of the home on that property. And we have an existing set of information that's going to allow us to draw the relationship between the home size in square footage and the property tax paid on that home. And with this information, we can go through, set up a regression equation, and we can make a prediction for what the property taxes would be on a home of any size. We're going to work our way towards over here is figuring out, according to the model that we set up, what is the estimated tax on a 4,500 square foot home in a New York City suburb. I could go through, I could manually do all the calculations in here. I could even go and shortcut it a little bit and use Excel's Corel and slope and intercept functions, but there's an even quicker way to go about doing this. And that is by using the data analysis Toolpak that comes in Excel. It is, however, usually not there by default, so you have to install it, which it's free to install, but you have to go through the process of getting it. So how you get there is you go to File. Once you're in File, you scroll down to the bottom and you'll see Options down here, and you can click on Options. And then when you're in Options, the next to the bottom one says Add-ins. Click on Add-ins. It gives you a bunch of options for the things that you want. The one that you want is this Analysis Toolpak that's up on the top. This is where everybody goes right. Make sure you hit Go right here instead of OK. So I'm going to hit Go to manage my Excel add-ins, and it's going to give me the options for what I want to install. The only thing I need is the analysis toolbox. That's the only check I'm going to have checked in, and I'm going to hit OK. And you will know that this has worked when you go to the Data tab up on the top, and over on the far right side, you see Data Analysis. So for Data Analysis over here, I'm going to click on that button that I just installed, and a screen pops up. And in here, there are so many things used in statistics that Excel has a function for that you can grab from this tool pack. We haven't gotten to a bunch of these things, but we talked a bit about histograms. We talked a bit about, we're working on regression right now on sampling. Well, all of these things are up in here, and there's a function for all of them. Just grab the one that you want, and the one that we want is regression. So I'm going to click on regression. I'm going to hit OK. And Excel is going to ask me for a few things. The first thing is my Y range. What Y values do I want to use for regression? X makes Y change. I have the size of the home and the property taxes that you have. Well, your property tax is based upon the assessed value of your home. And the larger your home is, the more it's typically worth. So we can make the assumption here that the size of a home would dictate how much you're going to have to pay in property taxes, which makes size your X, your explanatory variable, and property taxes your Y, or your response or dependent variable. So for my Y range, I am going to go and I'm going to highlight everything. I'm even going to put the header on the top of it for property taxes. My X range, well, if property taxes is my Y, size in square feet has to be my X. So I have this set up on the top right now. I did choose to put size and property tax in here when I was doing it, so I want to make sure I have labels on. I'm going to click labels. And then down here in the output options, you can go through and you can determine where you want to put things. You can put it in a new sheet or you can put it in the existing page that you're working on. And I'm going to go and put mine in a convenient spot right underneath my information. I'm going to throw him up into cell, we'll say D11, and I'm going to hit OK. And when I do that, Excel spits this out at me over here. And with that information, I can use it to make my regression equation. So what I have to work with over here is a whole bunch of information. And as this class goes on and as you get farther into statistics, you'll learn what more and more of this stuff means. But for right now, I'm only concerned with four numbers. The first being this up here, our R square. So I'm just going to highlight him because I know I'm going to use him, make him yellow. I'm also going to talk briefly about the standard error of your regression. So I'm going to highlight him, but these are the two biggies that I want. The regression equation is equal to your intercept plus your slope times x. Well, that's what these coefficients represent. The first one is your intercept. So if we went through and did the math the long way, we determined that the intercept for the relationship between size and property tax is $6,499.41. That's theoretically how much you have to pay in property taxes with a 0 square foot house. And then this is your slope. I'll actually make him a different color just so we can differentiate between the two. That is how much your property taxes are expected to increase because it's positive for each additional square foot that your home is. So instead of going through all of the calculations and using all of these separate formulas, using the regression packet within the data analysis Toolpak, a couple of clicks gives you all the information you need to work with. Over here on the side, I have the way to set up my information. So my first thing is asking me to compute the estimated value of a house based upon that square footage. We need the formula. Well, it's equal to y hat equals a. That's our intercept. And we have that down here, $6,499. And there's some change in there if I want to increase the decimals. There we go, and 41 cents. Plus our slope, which is this coefficient for size in square feet of $6.81 rounded off times x. And now I have the regression equation. Whenever we make a prediction for a house's size, we're going to take $6,499.41 and add to it the product of $6.81 and the square footage of the home we're estimating for. Well, in part B down here, we're estimating for a 4,500 square foot home. So I can say this is equal to A plus B times X, where X is the square footage, in this case, that we're estimating for 4,500. And zoom that out a little bit. Our estimation is saying in this case that the estimated tax that you would have to pay if you lived in a New York City suburb and owned a 4,500 square foot home would be $37,127.58 a year. Yes, New York City property taxes are absolutely insane. How good of an estimate is this? Well, we have a couple of things that we can use to make a determination. So I'm going to start with the standard error of the estimate, and that's given in the regression statistics up on the top. According to the output that we got over here, our summary output says that the standard error of the estimate is $6,641.92. What does that mean? It's essentially the standard deviation for the prediction that you get for your regression equation. And the same distribution applies. About 2/3 of the time, your actual number is going to be within one standard deviation below or above the number that you've predicted for. So if we're predicting for 37,127.58 for this particular home, if we kept predicting for other homes in this case, the vast majority of the time, 2/3 of the time, our prediction would be within $6,641, either below what we predicted for or above. You know, look another way, you can see the range would be about somewhere between 31,000 and 44,000 would be what the actual property tax would be 2/3 of the time. It's a pretty big range. Like missing your property tax estimate by $6,600 wouldn't make people even in New York City happy. So why isn't it the greatest predictor in the world? Well, what is our coefficient of determination? And our coefficient of determination is our R squared. And you've used the Corel function at this point to find your R. Well, R squared is just like it sounds. You would square your R. And it comes out to 57.56 or 0.5756. I'm actually going to change this to a percentage for a second. It makes it easier to talk about. The coefficient of determination is an analysis of what percent of the variation, the change that you have in your y, can really be explained by the thing that you're using as your x. In this case, what we're saying is about 57% of the change in property tax we are estimating is attributable to the size of the home that they're assessing tax on. But that's not the only thing. There's other factors that go into what your property tax is going to be. Even if this is all in the same suburb, in this case, maybe they have a downtown district that has higher property taxes than being on the outskirts. If there's some spot around here where there's water, if your house is on the water, you're going to pay a much higher property tax for waterfront property than you would for inland property. And also in New York State, as a tax guy myself, there's a bunch of tax exclusions that you can get based upon your status. For example, if you are a senior citizen, 65 or over, depending on what county you reside in, you can get up your assessed value of your house reduced by up to 50% because you're a senior. So there's other factors that go into how they determine your property tax besides just the size of your home. And we don't have a full 100% right here. Where's the other 42.5%? Well, it's the things I was just talking about. There's other reasons to explain your property taxes besides just the square footage of a house. In this part of the course, you're only using simple regression, just one predictor variable to determine your response, to determine your why. Well, in real practice, there's a lot of questions. There's a lot of things that go into determining it. So you might not just have one predictor variable or one B. You might have a magnitude of them. You might predict things based upon four separate variables, and we might touch some of that in this class as we get a little farther in. But for now, just using this one predictor, how good of a prediction is this? It's okay. It's definitely logical to think that bigger houses are going to pay more in property tax, but we've got a lot of variance going on over here with our standard error. This thing could miss by quite a bit uh, from what it would estimate, and that's because we're only taking into consideration a little more than half of the thing that truly drives up property tax. We're not accounting for the other things like age, waterfront, etc., that could factor into what your property taxes are going to end up being.